Hey everybody, how's it going? Hope you're having a lovely evening. I've got a bit of a mess here while I mess with my new setup. I wanted to show you how to fix something that is 52 years old. I'm not talking about the cat. The cat is 15, which technically I think in cat years would make her 80 or 86, but we're not fixing her. I got her fixed 15 years ago and once was enough for me. This is a Marantz 1060 amplifier, and I wanted to show you a trick when working on these to repair them that I learned when I worked at Avatar Studios with Ricky Began. I worked there when I was 17 years old as an intern with Ricky Began, Roy Hendrickson, Gretchen Mathwich, and Phil Lipscomb, and they were the best influences on me as a tech that I ever could have had. I was a teenager with a shitbag attitude, and they beat into me the idea of having pride in your work. But they also really good at teaching me a diagnostic skill set, especially Ricky Began. I would have never grown up to be the person that was telling people, like, yeah, check R7402 from like 2,000 miles away, and them going, how'd you know it was that? That all came from people like Ricky Began. They taught me this diagnostic skill set that stuck with me with anything I worked at. And I wanted to show you one of the tricks that he showed me. He had so many of them, and it's so very useful if you're an enthusiast for old audio gear and you're working on stuff like this. So I like this thing because of the tone controls. I'm not one of those people that believes that you can hear differences in power amps or preamps. As long as they're competently designed, they're designed to be neutral. They're not designed to have different sounds. So when people are like, this is warm, this is musical, this is analytical, like, they're all full of shit, in my opinion. They're all just fucking full of shit. If you were to take an Adcom $200 amp from the 80s, and you were to take some Krell $30,000 amplifier, as long as you're driving them within their limits, if you put them in an ABX blind test, which is this little box where A is the $200 Adcom, and B is the $30,000 Krell, and X is random, they would never in a million years be able to figure this out. You know, in hydrogen audio, I think the standard is you got to get it 12 out of 16 times in order for them to consider that you actually heard the difference. I mean, they would get it like less than 3. I guarantee it. Anyway, I didn't buy this thing because I believe that it's warmer or analytical or any of that horseshit. I got it for the tone controls. So the tone controls on this are kick-ass. So if you want to have that U-shaped frequency response when you're listening to heavy metal, the mid control on this is better than almost any amplifier I've ever used, besides something like the Pultec EQP1, which is, I think, $6,000 used now. So screw that. And it's also got this loudness button over here that I wanted to talk to you about. The loudness button is a really cool bass control. So normal bass controls just boost the bass, but that by itself is kind of boring. What a loudness button does is it takes advantage of an interesting weakness in human hearing, which is that as the volume goes down, our sensitivity to bass goes down. So what this does is, let's say I'm listening to music over here and I put loudness on. As I lower the volume, the bass is going to go down at a lower rate than the rest of the music. So as you lower the volume, you'll be able to listen at a lower volume but still feel like you have the bass that you did before. And it's also, again, this really is an art thing to it. They've gotten the loudness control on here. This little button, it's not just about bass and how it changes the volume as you lower the volume control. It just makes the music fuck. I don't know how else to describe it. You hit this button and it's just like the music fucks. It's awesome. And it sounds as awesome now as it did when I had this thing as a teenager. I was moving and this thing was broken and I never made the time to fix it, and I got thrown away at some point. So I got myself another one. And the problem is that I got it from eBay. When you buy stuff on eBay, you're always going to get fucked. That's the way it is. But it's hard to find stuff that is this old. And so this has this bullshit like most garbage on eBay does, where like, final past inspection, look at this. No, it's not. It doesn't fit. So I'm going to show you this thing doesn't work, and I'm going to show you how you would go about diagnosing it using one of Ricky Began's many tricks, which is the pen trick or the pencil trick. So first things first, I'm going to play a song for you that I don't think YouTube even knows the name of. I got this song from the Womb forums. It was posted to some random thread where you're supposed to judge somebody's quality of their mix. And I'm going to change the balance from left to right, and I want you to see if you hear what's going on here. So the left channel has this horrible veil over it. It's kind of like a blanket is over the speaker. And the right channel sounds beautiful. So I'm going to, just in case my microphone messes up, I'm going to play you the left channel, and I'm going to play you the right channel, but I'm going to tell you which one is which as I switch. So let's get started. I'll play some music, turn this thing on, make sure my amp is turned on. My amp is not turned on. There we go. Okay, so I'm gonna play the left speaker first. Now the right speaker. I had the loudness button on there for a moment. Let me just turn that off. Okay. Left speaker. Right speaker. Right speaker. Left speaker. Right speaker. Left speaker. Right speaker. Yeah, the left speaker just sounds like ass. And when I put the balance in the middle, you hear all the treble on the right side. And sometimes the left speaker goes out altogether. Now at this point you may bang on the thing, right? But that's not gonna do it. So let's open this thing up so I can show you Ricky Began's technique. Because I'm a fuckwit, I'm going to open it up without unplugging it because it's late at night and I'm lazy. Do as I say, not as I do. Don't do this. And if you do this, don't be so fucking stupid that because you're lazy and your keyboard's in the way, you're grabbing your screwdriver by the metal end. This may surprise you, but I got shocked by a Pultec EQP1. I forget which one it was. Whichever one had over 300 volts in it. Oh man, that was painful. After that, this thing's probably like only 60 or 70 volts of DC. I mean, I've gotten shocked by more on my electric bike. Okay. Don't do this. For the love of God, don't do this. Don't be a fucking idiot. Get up and unplug the amp. This is ridiculously stupid. I was about to use an R word, but I'll just keep it at Rossman. This is a Rossman thing to do. Yeah, that's the R word that I'll use here, because it perfectly describes me. Okay. There we go. It says over here, do not remove cover. And we're going to remove the cover. Now on the back of it, you'll see that it says that it's been serviced. And I got this thing on eBay. That's where I found it. So everything on eBay is complete bullshit, but where else are you going to find some 52-year-old gear? See where it says final passed inspection? Yeah, it said in the title that it was serviced recently and tested, which is your standard eBay horseshit. So what happens with old audio gear is it's very similar to what happens with MacBooks, where when they say serviced, what they actually mean is like they refloat it. So on a MacBook, if somebody's brain dead, what they used to do is they used to put the board in an oven and say, oh, it's fixed now. And on amplifiers, what they do is they'll replace 2 or 4 caps in the power supply, and then they'll say, look, we serviced it. Which, I mean, technically, it's not exactly the same as reflowing a MacBook, because if these caps are 52 years old, it makes sense to replace them. But that doesn't mean you serviced it. Like, did you replace a lot of the carbon resistors with new metal films? Did you go through and check every one of the solder joints? And there's a really easy way to go about this, and it's much more effective, I would say, with carbon resistors than it is with almost any other type of component, because of the way that carbon resistors fail internally and how they crack in a way that I just haven't seen with metal film resistors. So carbon resistors, very often they physically crack. And so one of the things that Ricky Began would do is he would take a pencil and he would use with a nice thick eraser at the end, he would put a little piece of tape or something around the metal piece of it so that you wouldn't shock things. And he would tap on each individual component right in the middle of it. Not on the legs, but in the middle of it, instead of just in the leg, because that will catch if there's an issue with the solder joint, as well as if any one of the individual resistors has failed. And I don't have a pencil, so I'm using a pen. The reason you would use a pencil is because it gives you a little bit of give. So I don't have, again, one of the reasons I don't fix stuff anymore is I have absolutely... Yeah, I mean, if you saw the last few videos before I stopped doing it, is my motor control is getting worse and worse over the years at a pretty rapid rate. So, I mean, if I were to do repair videos, it would just kind of be just embarrassing at this point. I'd just be making an idiot of myself, kind of like an 80-year-old person trying to box. But what he would do is since he had the end of the eraser, and it would have this, it had this natural bounciness to it, if he had a good eraser at least, not the dry ones. When you tap the component, you have a little bit of give before you put full pressure on it. And that's what he wanted. He wanted to be able to like put a teeny tiny bit of pressure and then before you put all the pressure. And he wanted to see how each component reacts to the differences in pressure like that. Because sometimes if you're working on gear that's 50 years old, you're tapping this, but you're really moving something over there. So I'm doing something similar since I don't have a pencil, which is I'm using this pen, but I'm using a pen that allows me to do this. See, it has a little bit of spring to it. So before I tap all the way, I would be able to kind of adjust how much pressure I'm putting there. What we're going to do is we're going to go through and see if anything causes my left channel to stop working. So I'm going to play that song again. And we're going to go through the inside of this amp and see if we get some easy idea of what's going on. And again, technically you could take the resistors and you could unsolder them and measure them out of circuit. Usually, actually, with capacitors, you would have to take them out of circuit unless you have a short to measure them. But with resistors, since resistors fail not by shorting, but by just not resisting anymore. I mean, not resisting. I mean, resistors fail not like a capacitor fails where it short circuits. Resistors usually fail just going in, from 10 ohms to infinite ohms, or 1 kilo ohm to 1 billion ohms. You can usually test them in circuit with some degree of confidence in what you're doing. But even that takes time. You got to grab a multimeter and mess with everything. And this way is much faster. So let's play something and see what we got. As you can hear, the left channels went off way more now, and it kind of comes back if I mess with the balance knob or the volume knob a little. See that? The first thing that you should do on something like this when you have that problem is ride the knob before we even get to anything else. Like this, in the area where it's messing up, you do that. Same thing with this. Just ride the knob. That sounds wrong, or as they would say in New York, pause. Dr. Evil Genius is watching this. I definitely heard him say pause. Now, I've already gone through that a few times and it didn't do anything. As you can tell, the left speaker still sounds like balls. Whoops, I thought that was the balance knob. Sorry if I made anybody deaf there. My bad. Okay. Right, left, right, left. So we still got that veil over it. So I'm gonna put this over to the left. And I'm gonna tap around. You tell me when you hear a difference, okay? Let me try it with my right hand. If I try it with my right hand, maybe I'll be able to hold it a little more steady. I'm not even tapping any individual component right now. Alright. Let's do this a little differently. No, I'm saying bullshit. Let's get the capacitor. I know, Clinton. We found it. I found you fuck. Found you prick. Let's do this again. This is embarrassing. Here we go. Bada boom. C407. Okay. Can we find a Marantz 1060 schematic on the internet? Let's see. Hello, BlackBerry. Yeah, I'm not putting much effort into production quality of this video. I was supposed to be in bed 2 hours ago. Marantz 1060. I know there's two versions of this. There's one that has the EQ. I think it's missing the mid control and it has sliders, and then there's the one with knobs that has the mid-range one. Let's see, Marantz service manual. Okay, this is, I'm gonna take a guess that any schematic I find is not going to be a searchable PDF. I don't feel like doing OCR right now because I'm holding my phone in one hand. Okay, let's see, C407. I'm gonna have you look at BlackBerry while I try to find that over here. Yeah, this is not, yeah, there's no OCR in this PDF. Look at this. You can see the paper and all that. Okay. Okay, here we go, probably around here. Now remember, this is the preamp section that's giving us issues, not the power amp section, because I'm using the preamp output. The only thing I care about here is the preamp loudness button and the EQ controls. So I'm using my power amp. I mean, this thing's like 30 or 60 watts a channel. I have 4 ohm speakers that are like 83 dB per 1 watt, per 1 meter sensitivity, something around there. So it doesn't make sense to use the amplifier section on this at all. Okay, I'm kind of curious where that is in the circuit. Where you get C407? Where's Paul Daniels' flex board view for his 52-year-old shit when you need it? I guess he'd have been able to make that software if only he had more fucking subscribers. You failure piece of shit, Paul Daniels. You hear that? You hear that? If you had more subscribers, I bet your software would work with this. That's an inside joke for those who are wondering. I don't hate Paul Daniels. I think he's an awesome dude. Highly accomplished professional. Here we go. C407, 3.3 microfarad, 20. Okay, this one's a little bit better. So here you have the inputs. Here you have the board that lets you switch between the different speakers. Here you have the board that has the filter on it. So see, you have the main, this thing, switch between the speakers. You have the low and the high filter over there. There's going to be the board that has the funky loudness control on it. Look at that. If I wanted, I could make my own loudness control, because back then they actually gave you the schematic, so I could figure out the secret sauce that makes the thing sound so cool. Build my own loudness box if I wanted to. Okay, this one looks a little bit better. So let's take a look at this. All right, so going over the power amp section, or how transistors work, you've probably heard transistors are used in amplifiers. If I go over this, you're going to probably want to cry. I mean, honestly, just looking at this, you probably want to cry if you're not used to how amplifiers work. Like, this is complicated and confusing as shit. And like, you get that a transistor is this thing, but like, what the fuck is going on, right? So let's go over how this works in a hyper oversimplified way. Instead of making you cry, I'm going to make EEV blog Mr. Carlson's lab and Mendit Mark cry with my horrible explanation of this as somebody who is oversimplifying it for an audience that doesn't work on audio gear, and as somebody who hasn't worked on this shit in 18 years. So a transistor has 3 legs, right? A transistor is simply a resistor whose value can change. Keep that in mind. A transistor is a resistor whose value can change. And over here, you have the 3 tabs of the transistor. You have the base, the collector, and the emitter. And the way this works is the base is the input, the emitter is going to be the output, and the collector is going to be what the emitter is outputting based on the base. So that probably makes no fucking sense. So take a look at my garbage illustration over here. Okay, you ready for the garbage illustration? Okay, so let's say that this is your music. Music is alternating current. So you know when you see a speaker moving back and forth like that, this is negative, that's positive. Negative, positive. You don't send DC, which is flat, just boring ass 80 volts, to your speaker, because then your speaker would just do this. And not only would the speaker die because you're sending DC and the coil would just get really hot, but also that's not music. You want to listen to music, which is the speaker moving back and forth. You don't want to just like have the driver move and just stay over here. That's not music. However, you need to have a steady reference voltage in order to actually create music. You cannot have AC voltage and the AC voltage then being used to amplify this AC signal. Using AC for this, it would kind of be like trying to play basketball as somebody's just dialing gravity up and down. It's not a thing. So at least for this piece of shit 50-year-old amplifier. So the way this works is we're going to take this 80-volt flat signal and we are going to try to modify it so that it looks like the incoming signal. So we're technically not amplifying, we're not making power here, right? Because this 80-volt signal, this is the max voltage. We're not going to be going above that over here. So we're not going above 80. What we're doing is we're not amplifying the 2 volts. We're technically shrinking the 80-volt signal to look like this 2-volt signal, but it's still going to be way more than 2 volts. So the transistor's got 3 tabs on it, right? It's got the base, which is going to be the input teeny tiny signal from your CD player. You're going to have the collector, which is the giant but boring DC voltage from your power supply, which is the power supply over here. And then you have the emitter, which is going to be the output, which is music, which is taking this 80 volts and modifying it to look like the base, which is the incoming. This is insanely totally oversimplified, but just so that you get what is going on over there. But now, why do you have all these different fucking transistors here? You have different stages. You're not just going to go from like input 2 volts to output 40 or 80 volts. That's not how this works. It happens in stages. And more importantly, you also have the output, the negative and the positive happening with different devices. So for instance, there's no need for the transistor for the negative side to be on when you're on the positive side, and vice versa. So like when the speaker is moving up here, right? Why do we want to power the transistor that's doing the negative half? So we could have the positive done by this set of transistors, the negative done by this set of transistors. And there's an entire thing called biasing that decides, okay, when is this transistor going to turn on? When is this one going to turn on? If you have it so that the transistor switches right over there, then you're going to have choppy sound. However, if you have both of these on all the time, then you have an amplifier that's using all of its power even when when it's not playing music. Like even when I shouldn't say not playing music, even when you're at this stage over here, when the negative section doesn't have to be on, it's still on. So that's highly inefficient. So you try to balance efficiency along with making the amplifier not sound like cock and balls, which is what. So you have a separate section for the negative and the positive. You have separate gain stages, and then you also have biasing, which is how you choose when these transistors are going to be on versus off. So if I'm going to have this transistor be on all the time, like more stable sound but absolute horrible efficiency, or I could bias it so that this transistor, like the positive one, literally only turns on right there, but choppier sound. So there's so much shit that's going on over there. But just so you get the basic idea, like base, input of your music, collector is going to be the high voltage, emitter is going to be your music, but more bigger. So that's pretty much that. Up here is the preamp. So that down there is the power amp stage, which is where you're taking the tiny voltage and turning it into a big voltage for your speaker. This over here is the preamp section, which is where I'm taking like the 2-volt output of my CD player or my MP3 player, and I can turn my volume knob to turn it into either a 0.000001 voltage signal, 0.1, 0.12, and so on and so forth. And so I can lower my volume, because again, connecting my CD player directly to this would mean I have one volume all the time, which would suck. So the preamp is going to be what allows me to lower my volume, but it also allows me to up my volume. So let's say my CD player only puts out 2 volts. Well, I can put out 0.001, or I can put out 3 or 4 or 5 volts. And that's going to be what feeds my amplifier stage over here. Now, the issue that I have is with C407, that capacitor. So we're going to hit C, Control F in my browser, and then I'm going to type in C407, and who the fuck am I kidding? This PDF is from like 1942. Okay, so where's C407? I see C404, close, warm. H406, H405, dangerously close here. Man, C407, here we go. So this is going to be a capacitor that blocks DC. All right, let's go over why that's important. So this is going to block DC as we go on to the next stage of the preamplifier. So why is DC blocking important? Well, as I said, AC is music. So AC is like, plus, negative, plus, negative, plus, negative, like plus, negative, plus, negative. Whereas DC is literally just taking the speaker from this state and pushing it forward, and then staying there or pulling it back. Like, there's a lot of reasons you don't want DC. And a capacitor is going to block DC. So again, this is going to make EV blog cry, but fuck it, it's 1 a.m. So this is the capacitor. So you have your leg of the capacitor, it gets soldered to the board, you have a plate, and then you have another plate, and then you have another leg, right? So what do you think happens when DC voltage tries to go to the capacitor? It just falls down. It can't go through it. It's sad because it just gets blocked, literally. Now, here's what happens when you have AC try to go through the capacitor. Remember, AC is this wave. It's, you got, so what do you think happens when the wave, since it's a wave, it goes up there, it jumps over, and says F you. So AC, which is music, will go through the capacitor. DC will not go through the capacitor. Now, if the capacitor starts to screw up, sometimes this is how a capacitor can short and let DC through. So for instance, like this is a functioning capacitor over here, and like this could be what a capacitor looks like if it's totally failed. So it could be something like this. The plates may kind of be like smashed together. So now there's no insulation, so it's conducting like a wire. That would suck. You also get capacitors where this just kind of wears out, so the AC is going through, but it's not really going through well, and that's the case that we have here. This capacitor, I believe, is there to block DC, but it is not just blocking DC, it is also fucking up my audio. And it makes sense because this piece of shit is like 52 years old. And this is the problem with this type of shit where it's like, I'm going to replace the output, I'm going to replace the power supply capacitors, and it's fixed now, right? No, it's not, you fucker from eBay. It is not. You get it. All it takes when you're selling old gear, it's the simplest shit in the world. You take a pencil with an eraser, or you take a pen, and you just tap on the shit on the board. Like, you don't even have to be exact, because you saw how little effort it took to tap on that. And here, that horrible shit. It really doesn't take much at all. But and you're going to see this a lot with old audio gear where nobody gave a fuck to do any of this. And you're going to have this stupid ass sticker over there that says past inspection. I can't tell you how much old audio gear like this is just, it's this half-assed MacBook reflow shit where it's, even if you don't know everything that you're doing, just like a little bit of basic stuff. This is why at Avatar Studios, I think they're in Berkeley now, they're not Power Station, but at Avatar Studios, this stuff is why a Neve 8088 console from 1977 still works and sounds as good as it did on the day that you bought it. That's why the LA2As, the LA3As, the 1176s there, the EQP1s, and all that stuff sounds as good as it did the day that they bought it, because the people that worked there instilled in everybody, from the old school technicians to the 17-year-olds, that this is the way you work on stuff. Like, you go through things methodically like that, and you think your thought through your thought process, and you don't just replace one thing. You go through everything, and this is a really nice way to be able to go through a lot of different components here, and without having to measure them immediately. It's a shortcut, and a shortcut like this is really helpful, because Neve 8088 is like what? I forget if it's 32 or 48 channels. I think it's 32 channels. You got all these different modules. There's a lot of stuff to go through. SSL J9000 is like 48 or 72. There's a lot of channels on this stuff. So it's helpful to have a shortcut. And hopefully this has helped you out. And hopefully I can get on to fixing this in a future video. And we're going to make this sound awesome again. And then I'm going to have my loudness button. I love my loudness button. It's the coolest thing in the world. All right. See you in the next one. Hello, Barry. Who's a good girl? What am I doing up at 1 a.m? Working on this stupid audio gear. I know. I should be giving you pets, right?